This video is on exponent rules or exponent properties, and we're going to be focusing on the zero exponent rule. The zero exponent rule states that any base except 0 raised to the 0 power is equal to 1. So any base raised to the 0 power is equal to 1. You still have to utilize the order of operations and know what is the exponent attached to, and that's where things can get a little tricky. So the general rule of this is x to the 0 power is equal to 1. There is a reason behind this, and I will explain that in just a moment. Our first example of y to the 0. Well, this 0 exponent is attached to this y. That's the only thing it's attached to. There is no other base around it, which means that there's no extra additional piece that we have to think of for the order of operations. The exponent of 0 is attached to the entire problem, which means that this entire problem turns into 1. That's it. On example B, we're looking at the exponent of 0. This exponent of 0, it says 7x to the 0. This exponent of 0 is only attached to the x. If it was attached to both the 7 and the x, you would need to utilize a grouping symbol like parentheses. There are no parentheses here, so this 0 is only attached to the x. What that means is that the 7 is not affected. That means we actually have to keep the 7 out to the side because we haven't touched it. Now x to the 0 power, that entire piece becomes 1. So we really have 7 times, and then x to the 0 is the 1. So what is 7 times 1? The answer is 7. Because this problem, the 0 was not attached to the entire problem did not become 1. Only the piece of it did. On this last problem, we have parentheses, 7a cubed b to the negative 1 parentheses raised to the 0 power. So order of operations, we look at the parentheses, and anything inside the parentheses we could simplify. But then we also look at the exponents. So the exponent's on the outside of the parentheses. The exponent on the outside of the parentheses is 0. Now this 0 is attached to the closed parentheses. So I'm going to start my box at the closed parenthesis, and that means I have to go to the open parentheses. So I'm going to draw my box until I get to the open parentheses, and then I'll close it. When I finish this box, I notice that every single thing in this problem is inside that box, which means that everything on this problem is raised to the 0 power. The entire problem is raised to the 0 power, so the entire problem is equal to 1. It does matter if when you're paying attention to what is the exponent attached to. And you'll see that in other cases that the parentheses are really important when you are trying to see what the exponent's attached to. Now I did say that I would explain why x to the 0 is equal to 1. If you think about the quotient rule that we've talked about, if I say x to the 5th divided by x to the 5th. Well, this is something divided by itself. These are the exact same thing. So we know that mathematically, just like if I were to say 3 divided by 3. 3 divided by 3 we know is equal to 1 because that is something divided by its exact self. This x to the 5th divided by x to the 5th is something divided by its exact same thing. This inherently is automatically equal to 1 because anything divided by itself is 1. That is an identity. But also understanding the quotient rule. This is a base of x divided by the base of x. And we know that from the quotient rule, if the same bases are being divided, we write the base and then we subtract the exponents. So we have a 5 minus 5, which in turn becomes x to the 0 power. This is the transitive property saying that since they are all equal to each other, x to the 0 would then be equal to 1. X to the 0 comes from the quotient rule, but it is a simplified version of the quotient rule where you didn't actually have to do the quotient rule. You get down to x to the 5th divided by x to the 5th, we know is 1, but 5 minus 5 is 0, so x to the 0 is equal to 1. And that is where the x to the 0 or the 0 exponent rule actually comes from. And I'm going to erase this. That was just a quick explanation of why the 0 exponent rule happens.